Hello, welcome to our 2020 Vision Features and Updates webinar here at SimScale. We're going to discuss some of our new platform features, recent updates, and just kind of talk about what we've unveiled so far this year. Additionally, we'll probably touch on some broader trends that you can expect to see from us as we progress into this year and this new decade, I guess. My name's Meg. I'm a content manager here at SimScale. Therefore, I'm normally typing instead of speaking in these webinars and videos, but I think I've been in one at SimScale. Do you remember that, Arno?
Yes, yeah, you did that well. I was also on one of the at SimScale. So.
Good. I've been here since 2018. Work closely with all of our teams to support our customers. And Arno can introduce.
Yes, so my name is Arno. You've probably heard me in the previous webinars and videos. So I'm a technical marketing specialist here at SimScale. So I work closely with Meg on all the technical content in blog posts, in tutorial videos, and all these nice visuals you see. I'm a mechanical design engineer as a background. I've worked with simulation tools for many years, and I'm part of SimScale as a simulation engineer working specifically for the marketing department here. So really with a focus on the architecture, engineering, construction industries. So a bit about SimScale before we get started. SimScale has been founded in 2012, and our offices are located mainly in Munich, Boston, and New York. We've got across 6 times or more than 80 employees, so we're really growing faster and faster. By the way, we have actually opened a few positions recently. In the customer success team, in engineering team, so in customer success as application engineer, product owners, and for the engineering team, backend developers, CAD and meshing software developers. So if you are interested, go on to simscale.com and you can also apply for these positions. In terms of the community we have, there's a huge amount of users. It's actually very impressive to see how many users we have on the chat, how many people are connected at the same time, how many projects are in the community part of SimScale. So yeah, it's really growing well. We have a nice forum where people can exchange projects, exchange ideas, and really make the world of simulation a really more accessible place, and this is where we're placing ourselves. So a bit about SimScale. So I mentioned the simulation world that we are into. With SimScale, we're trying to implement an engineering solution platform within the web, accessible from wherever you are, as long as you have a web navigator or web browser. And we implement solutions for fluid dynamics, solid mechanics, and thermodynamics, so all in one single platform.
So our topic today, SimScale 2020. So I think we should also mention that actually end of last month, we did manage to close 27 million in Series C funding led by Insight Partners. So with that, you can expect a lot from us this year. I think before we talk about kind of the trends, we should just say what our company manifesto is, which you can find on our webpage. So here at SimScale, we dream of a future where engineers are able to optimize their designs better and faster. We want to be the destination for designers across the globe by providing a cloud-based simulation tool, educational hub, and collaborative community of innovators. So with this, some trends you can see are continuous updates and improvements to our platform. So we're planning to announce recent updates and feature additions and just general improvements really for all levels of our users twice a month, and you can follow this on the blog. Also with this, we are working towards making the whole SimScale experience as seamless as possible from pre-processing to post-processing. The next trend you can see is customer cultivation. So in the works right now, we're trying to plan some actually in-person customer events to support our existing customer base as well as future customers. Working more than ever to create success stories and really work with customers to cross-promote what we've done and what they do, and we're always striving to improve our relationships with these customers, as well as call time and our help services when needed. We are also taking suggestions from users and customers alike and implementing them into the platform quicker than ever before. So you can also follow this again if you follow the blog and see our continuous updates and improvements. Lastly, and I don't want to touch on this too much because we will have a lot of noise about it next month, in 2020 we want to add cloud-based collaboration features for our professional users. So this will allow teams to work together faster and better. And like I said, there's more to come on this in March. So please kindly reserve any additional questions until then. We will be more than happy to answer next month. I just wanted to touch on this.
Mm-hmm. Yeah, I'm actually very excited about this new things coming up. But you will know more. It's just a huge step into the game of having this integrated into a team. So that's going to be very, very interesting to see.
It will be good.
Yep.
Okay, and so with this, then we're going to touch on 11 new features / improvements that we are pretty excited about. And then Arno's also going to show you how you can enable these and use them yourself on the platform. But with, it's 11, so we've decided to categorize them into 3 overarching topic areas. One being general simulation features. So these can be accessed and used by all kinds of users. And they're all aimed to just improve the overall user experience, as well as they're all created from user-generated suggestions. So really, we take user-generated suggestions pretty seriously here. We also want to make sure that we are not ignoring fundamental functionality faults that we have or flaws. We don't want it to see, we're not just adding new features, we're constantly working to update what we already have. The second revolves around heat transfer. So a recent feature that we've made to our conjugate heat transfer, and this can also be accessed by all users. And the last but not least, pedestrian wind comfort features. So as one of our newest focus areas, we're constantly updating and improving this analysis type to empower architects to be able to validate their designs earlier in the design process than before, but also so that they can do this quicker and incorporate it into their workflow very easily, as well as export results faster and just in the best way possible.
Yeah.
So without further ado, we will begin. And the first feature that we will talk about is an update to what we already have, and this is to help you identify CAD issues. So a CAD fault is just when a model or a file or geometry has missing information. And this can be a problem for new users or just people new to simulation in general. I mean, it's definitely, have you seen lots of cases of this?
Yeah, so the idea is really trying to make sure you have a right model before you start your simulation. Yeah.
And we basically just want to let our users know if they're going to go down a failure workflow, we're trying to stop it at the very beginning, so just to eliminate any problems.
Yeah.
So I think the best way to show this is through some examples.
As we say, the right simulation starts with the right CAD model. So we really want to make sure that we have this right step correct. You know what you're doing from the very start, and you don't end up with surprises down the line, and then you have to do everything all over again, or your simulation fails, or your meshing fails. So we're trying to make sure that we tackle this problem before. So yeah, I'm going to show you an example on the platform of what can happen when a faulty geometry is uploaded. So here it is. I think you can see my screen again. So this is an air intake that we've taken from a step file. So this works actually with any type of CAD model. So regardless if it's step file, Parasolid, or SolidWorks file, Rhino file, anything, you will see that if there is a problem in your CAD and it cannot be simulated, you'll have this error message on the left-hand side, geometry contains fault. And on the right-hand side, you have the list in your tree here of what is wrong and where it is. So if I click on this, for example, it will tell me and highlight what it is, what edge is concerned by this bad edge vertex. So if I click on it, it's going to zoom into that problem. And I can easily identify, okay, well, this is something clearly wrong here. I have a vertex that is touching some other edge and I want it. So this allows you to really see, okay, this is where it's at, what the problem is. So what we can do is that we can go back to our native CAD environment. In this case, what I would recommend is just delete that part and then do that a circular pattern, because you see it's a circular pattern. So you can do that circular pattern again and you'll have it fixed. Another example of what a CAD fault could be is, let me bring that again here, is when you have, when I import this manifold here, you see, we have a self-intersecting geometry. And this is highlighted here. You see, we have a face that is kind of wrapped around itself, and that's not what we want. So again, if I click on it, it's going to highlight it with a little cross here, and this allows me to know, okay, this is what the problem is. You see that it's also repeated in different cases. So you see it's probably coming from a pattern that hasn't been properly set up at the original entities. So what we can do, we can go back to our original CAD environment, delete these faces, and probably patch them, or we do that fillet. I think it comes from a specific fillet. So basically, this is the actual workflow that we'll suggest. We have a blog post about it again, Meg, I think, where we discussed the CAD faults a bit more in detail. You have these kind of examples, so if you want to know more about it, please go and visit the blog as well. Okay, so let's go back to our presentation and the next feature that we have. Unless you want to add something on this, Meg?
No.
No, that's good.
Very good job. Cool. Yeah, so moving right along, the next feature we'll talk about, now we have automatic chord choice for meshing and simulation. So before, there was a bit of confusion because users could pick between 1 to 96, or if you were a community user, 1 to 16 cores. Mm-hmm. So now, the variables determined in your simulation setup, meaning the complexity, size, and parameters, are automatically inputted and then outputted into a correct number of cores. So this means that there's no more arbitrary choice and mistakes. Mm-hmm. This is a default for all of our users, but professional users can still have access to selecting the amount of cores if they desire. Mm-hmm. So all in all, this is more efficient runs with fewer core hours used. So Arno, didn't you once make a mistake where you used too many cores? Yes,
as I first started SimScale many months ago, I was a bit confused, and this is, I don't think I was the only one in not knowing the amount of cores I needed for my runs and the number of core I needed for my meshing as well. So it was very confusing to know, okay, if you have this size of mesh, or if you have this amount of features in your model, okay, what's the right amount of cores, and how can I make this very efficient? And a lot of people, I think, are confused as well in the fact that SimScale is an online platform, and we have the power of cloud computing. We can use a huge number of cores. You can use up to 96 cores. The problem is, when you use 96 cores for a simple problem, it comes down to a similar situation where you have 10 people trying to cook pasta, and that is trying to have a lot of different resources for one single job. So to coordinate all these different people to cook this amount of pasta, that would take a long time. A lot of coordination is necessary. A lot of work to organize it is necessary. And this is what happens when you select a huge number of cores, or like 96. We need to organize the runs. We need to split down the model in order to run it. So it ends up quite often that you use a lot more cores, the CPU hours, than you would need originally. So when I first started, I had this. I'm going to populate it here. I don't know if you can see. Yeah. Here, I have my, this was a cyclone analysis where you see in the simulation control, back in the days you had only the selection from 1 to 96 cores. So for me, it was like, okay, that's a model. I want to have it very quickly run, and it has to be a quick run. So I would select 96 cores, and this is what happened in my in this run here. You see here, AR.319, and I've used almost 420 CPU hours, core hours, and using 96 cores. And earlier today, I went down and chose automatic core for the exact same run. And you see that I've used only 330 core hours. Of course, it took a little bit longer, not so much, but I've used nearly 100 CPU hours, core hours less for the same results. So this really helps you to not think about how many cores you're going to use for this specific run. It's automatically populated, it's automatically chosen. There's something in the background that analyzes your boundary condition, analyzes the mesh, analyze how long you're going to run it for, and it automatically makes this choice for you. So you really have more efficient run and use less core hours. So you don't do the mistake I made back in the days, basically. Okay, next one. Yeah, I think this is a nice. It's a simple feature, but I think it's really nice. It's aligned with having a really nice user interface, having a nice environment, and having the idea is to have your model, whether it is in the pre-processor state or the post-processor state. So this is the image you see that we are post-processing results, and this specific feature concerns the zoom feature that is going to happen wherever your cursor is of your mouse. So this allows you to really target where you want to zoom, and the zoom is going to happen not at the center of the display unit, but where the cursor is. So you can really zoom into the components you want. So this is one of the first features of the interface that we have implemented. A lot of them are coming up in the pipeline for this year, and this is actually a nice addition. I think we've also updated the color scheme, and I think it also looks way better than before. So yeah, there'll be a lot of functionalities in for our user interface, and this brings us to the post-processor interface. So again, we're trying to make this transition as seamless as possible, trying to make you guys interact more with the model. So not only inputting coordinate, but also allows you to interact with the model, interrogate the model before and after the run. So this is a perfect example here that we have when we create geometry primitives. So the geometry primitive, as a reminder, allows you to create a refinement zone, allows you to create momentum sources or porous regions and things like this. So you can now interact with the model and pick points at specific location on the surface of your model. So this allows you to have more of a precise input. You are sure that this point is on the surface, and this helps you a lot to define your cubes, to define the boxes, the cylinders, and the probing point. I use this a lot myself when I want to probe a certain location, and you just have to tick that box of the little what do you call it, small target, and you can pick the point on the surface of your model. So really, really useful. It's a nice addition. On top of this, you can now, it will come, I think already, if it's not already there yet, you can duplicate the boxes that you create. So you see the box that is created on this on this little animation, we can now pattern it. So if you have like a row or a table of different, for example, fans, so I'm thinking about data center where you have a lot of different fans, a lot of momentum sources in your model, we can actually pattern these blocks and space them equally across a certain length. So that's really useful. So that is something we are really keen on developing and making it super, like, a lot more accessible for you guys to set up the model, for example.
Good.
Yeah.
Okay, this is our last feature to discuss in general simulation features. So we have now added scientific notation for value inputs. So this is purely for improving visibility, usability, and clarity. It was a user-generated request that we've implemented. So this is a good example to show that we are constantly listening to our users and customers at any stage of their simulation experience. To try to improve the platform for them. So again, we've said this at the beginning, we'll say it again and probably throughout. If you do have suggestions or improvements you want to see, please reach out via chat or email or in this webinar.
Yeah.
But yeah, so the image that you can see on the right shows, it will always show in this notation now when it is not focused. And then on the left, that shows like if you're trying to input your values. Do you have anything else to add?
Yeah, simply to avoid having all these zeros here that you're like, okay, like how many zeros is that for the kinematic viscosity? And you have, okay, 1, 2, 3, and then you can on the right hand side know exactly what value you input it. So it's less confusion, and you'll have more. It's more something that is displayed for in the scientific community. You have this notation is widely used, and you can see yourself, like it will speak to you better, I suppose. Yeah.
Great. Okay, moving on. So now we will talk about the feature that we've added for conjugate heat transfer. So we've added radiation. So with this addition of radiation, we are now able to tackle all kinds of heat transfer. Previously, this was only available where there was fluid volume. And we've decided to add this because where higher temperatures are involved, this becomes very necessary. So if you're working with an application of more than 70 degrees Celsius, radiation starts to be a very significant factor. And you can see a difference of up to 10-15% in the results, really. We don't have a project right now to discuss on this because it's quite new. So we are going to put out content in a video soon showing how this works and highlighting the key differences. Would you like to elaborate on this at all?
Yes, it's really to give you a simple example of where this could be useful is, for example, when you have a block that we're heating up really much to, let's say, 500 degrees, a block of steel, for example, and the steel start to change colors. This is what you see when you heat up a metal, and this starts to have a significant radiation emission. So we're not able to tackle this kind of analysis where bodies can emit or receive or absorb radiation. So this makes this conjugate heat transfer a very complete feature in terms of tackling all the heat transfer means all in one type of analysis, basically.
Right. And as said, we will have additional content on this coming out very soon. So now we are going to move on to our pedestrian wind comfort features. So just to touch on this a bit, traditionally it was very close to impossible for architects to perform wind comfort analysis on their designs. They would need to rely on simulation experts and consultants to get a good estimate on the impact of the building that they were proposing or the area around it. And this is very important when you're thinking about pedestrian wind comfort and safety as well for the designated outdoor area usage of a building, as well as just the sidewalks and surrounding areas. So wind comfort assessment used to be pushed very late in the design process and would only kind of be accessible through wind tunnel testing. But we've decided to invest and build upon this analysis type because, as I said at the beginning, we really want to empower architects to be able to validate their designs already in the really early stages of the design process. So that way they can find if there's any issues, or they could have more confidence when submitting their final designs to prove that there is good wind comfort. So with this, we will talk about our first feature that we've just added, which is porous region integration. And this allows us to define certain regions or volumes that would correspond to trees and bushes. So ultimately, you can use this feature to better define trees in the immediate area. There's going to be more on this soon, and more about different tree types. Do you want to explain the project that we did?
Yes, so I'm referring now to a blog we did last week or 2 weeks ago, I think, where we simulated the wind in Bryant Park. So that's the area of New York where the Grace building is, and this is where our investors, main investors' offices are located. So we wanted to see with this porous region kind of analysis, what is the impact that the tree would have on the development of the flow in a certain region. So on here you can see that with the wind coming from a specific direction where it's facing the main building of interest, we have what we call a downwash effect, where the wind hits the face and then go down and flows down and accelerates as it reaches the ground level. So you see that we have this kind of swirl phenomenon. It just comes down and swirls back and creates high velocity, as you see on the left-hand side. On the right-hand side, we've managed to implement the effect of the trees as some sort of zone. And with a specific porosity, as Meg mentioned, we will be able to implement different type of trees with different porosity. They will oppose a certain resistance to the wind across their volume. And we can demonstrate that the trees have a beneficial impact for the wind. Usually we plant trees also for CO2 emissions and things like this, and making the urban environment more green, but it's also an application where trees can be beneficial. So we are really trying to promote this aspect as well. So I think more content will also come when it's about implementing trees for wind comfort. It's a really nice way to mitigate the effects of uncomfortable situation where the wind is involved.
Definitely. Mm-hmm. And if you do want to read more about this, you can look at our case for the Grace building and what we found. Mm-hmm. It was very, very interesting.
Yeah.
So the next feature we want to talk about is weather data input. So now customers don't have to gather and upload windrows data manually anymore. It's now possible with just the click of a mouse. And we use MediaBlue. And this is a centralized database that relies on historical data and meteorological data and real-time data. So it leaves less room for error, basically. Mm-hmm. Do you want to expand on this? Or?
It's basically, yes, it's a partnership we have with MediaBlue, and it allows you to just simply automatically import this data by just you're just typing the zone where you are, so London, or anywhere in the world, and you'll have this data populated for you. Mm-hmm. It's a nice addition, I think. Yeah.
Mm-hmm. And our next feature is now we have the ability to assess 36 wind directions at the same time. So we used to have 16, mm-hmm. And now we have 36. And this is because there are some users that probably need to have their designs conform to higher wind standards where high resolution is required. Specifically, probably Lawson and Davenport, mm-hmm. and NEN require this. So now we do have this functionality. Mm-hmm. But we can still scale it down.
Yeah, you don't have to run the simulation in 36 wind directions. So yes, you can now have the option to run it even in one single direction. It's just an operation done in the background to really redivide the overall wind directions without losing on accuracy and things like this. So yeah, it's quite useful when you want to save on computational hours. Also, yeah, as a reminder, all these directions are being performed at the same time as well.
The next feature is we now have NEN 8100 wind standard calculation. So this could be easily confused with there's two NEN standards, basically the wind engineering standard and the wind comfort standard. We've had the wind comfort standard for some time. So with this update and addition, we now fully support the complete standard, including uploading the datasets from the official government resource, the NPR 6097 program. So currently, just to reiterate, I guess, we can calculate wind comfort plots for Lawson, Davenport, and NEN. I think we'll show a bit more on this slide later.
I think it will come exactly on time for our last feature.
And the final feature that we want to talk about today is our new post-processing interface. So SimScale has released a completely reworked interface for pedestrian wind comfort data. Again, this is for professional users only, but I think the best way to show this is by showing the platform. So over to you, Arno.
Yep. This is this is also something I'm very excited about, having a really nice environment for post-processing my data. So first, what you see here is a bit of a reminder of what we saw before, having 36 wind directions. You see all the direction on that wind rose, so we're not able to import these on the platform. This is actually a project that I took from our product owner, which is Richard, and I think you've heard about him before. And I'm actually seeing his project, and I can interrogate the result of his simulation, which is actually kind of cool. So we can really interrogate and see what the person is doing when they share the project with you.
Cool.
So let's dive into, actually, yes, we have these 36 different directions. We can select how many directions we want for our run. This is a nice addition that we talked about. And diving into our post-processor. So this is valid for the statistics, the wind comfort criterion only at the moment, but it's going to be available quite soon for the rest of the results. This is
and
what
again,
it looks like.
I think we should reiterate that if you do want to keep an eye on when we are going to unroll this out or roll this out for other analysis types, just keep an eye on the blog and forum, and just keep an eye on SimScale, basically.
Yep. So what we have here is I'm going to show actually a better result with a more defined result. So you can see that the wind comfort criterion, they load very fast. As you can see, it takes a few seconds just to populate all this data. It's millions of cells that we can observe all at the same time.
Whoa.
Exactly. So yes, we have all of different wind comfort criterion that we can select. So from Lawson to Davenport. So these different criteria, again, I think we did a blog on this to explain what they are, what these different categories mean, or the different threshold, speed, and probability. So if you want to know more about it, there's also content where we explain all what this means, and it's still ongoing. We still have a lot of things to explain to you in the pipeline, and we're very excited to do so. So yeah, really into a bit more about this new post-processor environment. So you have the possibility of course, changing the display. It's a lot better in terms of deciding what kind of result you want. You can toggle between perspective and normal orthogonal as well, which is something we didn't have before.
Wow.
Yep. And we can interrogate the result very quickly by doing the inspect point. So if I want to know, okay, what is that here? I'll have my results automatically populated. So this will become available also for normal type of result like velocities and things like this. So we're heavily developing that part. You can obviously hide different parts like you used to do before. So then hide all these and so on. So it'll be even more than that. There'll be animations, there'll be screen captures and all these. So that's very exciting times ahead of us. You're going to be able to save views and things like this. So yeah.
Awesome.
If you have any, did I miss anything, Meg, or do you know?
No, thank you. Maybe just show the NEN.
Yeah, we have NEN actually already implemented. So as Meg mentioned, we have NEN comfort and NEN danger or engineering comfort as well. Like this. Also, we can interrogate our data like this. Again. Yep. Let's go back to our presentation here.
So at this time, we are done with talking about all the features and updates, actually. So we do have some time for questions. And so we can just wait a moment and see if they're rolling in. So we do have one question regarding porous media. Do I need to know the specific porosity parameters for the trees? Where do I get them from? No. No, you do not. You can use our preferred tree model properties, but we've already implemented specialized tree models.
Yes, so at the moment we can input a specific porosity parameters for any zone that is considered porous. But soon we will have the implementation of the type of tree. So it'll be like embedded or like already set up type of trees, so plane trees or cherry trees or what have you. So yeah, there will be already inside the platform, a bit like a populated material, like a library of material. You'll have a library of trees, for example.
Very cool. Very cool.
So I have another question. Is there a possibility to change the geometry directly in SimScale in case of a little change? That is at the moment not possible, as SimScale is not a 3D modeler but more of a simulation platform. What we encourage people to do is go on to Onshape, which allows you to really quickly make changes and is fully compatible with SimScale. So if you don't have an issue, if you can fix the issue with Onshape, you can be guaranteed that you will not have an issue importing this onto SimScale. So that's a nice and a good workflow that I would recommend is to really fix that before importing on SimScale. Yeah.
Okay, next question. Can I get the wind comfort criteria evaluated directly on balconies or rough terrain? I believe yes. Arno, would you like to expand on this?
So actually I can show you on the platform directly. So if I go back here, when there is a specific, when you set up your pedestrian wind comfort simulation, and you want to select your pedestrian comfort map here in that section. The pedestrian level is ground relative, so we can use the terrain of your CAD data. You can also use the zero plane if you don't have any terrain data, any terrain that is modeled as a surface. And you can also pick any other face. You see that they don't correspond necessarily to a terrain. They can correspond to an upper level or a terrace or a balcony. So it doesn't. You can pick any kind of face on which you want to see your pedestrian comfort, on which you want to see wind comfort criteria. So it's definitely possible.
Awesome.
Okay, I think we talked more than we planned to at this stage. Maybe I'm talking too much. I don't know. I hope it's clear. I hope we answered most of your question, and I hope you have a clear idea of what we are trying to implement and trying to make the simulation better as well for you, listening to you and your suggestions.
Yeah, as well as have a better idea of where we're going this year. And if you want to see more from us and what we're planning on doing, as we've said, just keep an eye on the blog, and we will roll out new updates and features very, very soon. Thank you so much for joining.
Yes, thank you guys. Yeah, it's been nice to show you. It's also very exciting for us to show you all these, because there's a big team of developers in the front end, in the back end, and engineering who puts a lot of excitement into this as well, and we're all very excited to show you all these features. So that's not simply that there's a huge team of developers behind us working on this. So yeah, thank you to them as well, I suppose.
Yeah, big thanks to them. Great. All right, see you next time.
All right, thank you guys, and see you next time.